element to make the array strictly increasing. So we are just giving a variable nums, so it is just the integers. Yeah, it is the positive integers from 1 to 1000. We just want to remove one element to check if the nums is strictly increasing, or we don't need to remove any numbers. If it is strictly increasing itself, we can also return true. Otherwise, we're gonna return false. So for solving this problem, I'm gonna use two ways. So the first way, I'm gonna just use the brute force, try to remove one number and one number to check if it is strictly increasing. So if it is strictly increasing, I'm gonna return a true, otherwise I'm gonna return false. So the second method gonna be the brute greedy idea to solve the problem. So let's try to use the brute force first. So yeah, for the brute force, so I'm going to check the numbers one by one. So for I in range length of nums, yeah, I'm gonna check the numbers one by one. So I'm gonna use a check function. This check function is gonna use to check if it is strictly increasing. So if it is at the index I, I'm gonna remove the current numbers. So it is nums I plus nums I plus 1. It's gonna be the next number. So for example, index 0, I'm gonna remove this number, so it will go to the next number. So 0 plus 1, it will from 2 to the last number. I'm gonna check. So if this is strictly increasing, I'm gonna return a true. Otherwise, I'm gonna return a false. Yeah. Now I'm going to use the check function to check if it is strictly increasing. So inside it's gonna be an array. So I just need to return O of an array. So it's gonna be so inside it's gonna be AI should be more than AI and minus 1. So for I in range, so from 1 to length of the array. Yeah. Otherwise, I'm gonna return false. So this is the brute force. Let me try to run it and check if it works. Yeah, as you can see, it works, but it's really slow because the type complexity is O(n) square. So this is O(n) and this is another O(n). So it is O(n) square, and that is why it is so slow. Now I'm going to use O(n) to solve the problem, but how can we solve it? Yeah, we can just change a little bit to use the greedy idea. So the greedy idea is we're gonna check the numbers directly. We don't need to use the brute force from here. Yeah, we're gonna check it directly. So for example, if this 2 is more than 1, it is okay. If this 10 is more than 2, it is okay. So if this 5 is not more than 10, it means there must be something wrong with this 5. Yeah. Or it can be something wrong with this 10. So for example, we can remove this 10, it is a true. Or we can remove this 5, it can also be a true. So for example, let me just copy the numbers. You're gonna see it clearly. So so for this array, currently while I'm loop through this 5, so this 10, I can remove this number 10. So if I remove it, it is strictly increasing. Or maybe this 5 can be another number. So for example, it is strictly increasing, but this 5 let me try to use another example. Maybe this 7 is 14 and this is 5. So I can also remove this 5. It is strictly increasing, as you can see. If I remove 10, it is strictly increasing. It is 1, 2, 5, and 14. Or if I remove 5, it is also strictly increasing 1, 2, 10, and 14. So in this way, I can use the greedy idea to check it directly. I don't need to use the brute force anymore. So the greedy idea is, I'm gonna check it directly. So for I in range 1 to length of nums, now I'm going to check it. So if nums I should be more than, if it is less than and equal to nums I minus 1, it means there must be something wrong with the current number I, or current number is I minus 1. I have to check. Yeah, if it is like that, I have to check. So if if it is like that, I can just return to check it can be a true or false. Yeah, so it's gonna be the check with this one and or another one. So this is the current number I, or I can check with I minus 1. And let me copy it, and here should be I minus 1, and this I plus 1 minus 1 should be I. Yeah, so if it is like that, it means it must be something wrong with nums I or nums I minus 1, so I have to check it. Yeah, so I'm gonna check if either one of them can return true, so I'm gonna return true. Otherwise, if it is not true, I'm gonna return false. Yeah, so if it is not like that, it means it is strictly increasing itself, so I'm gonna return a true. As you can see, so for this one, there's only if check, and this check is only for and this check is so for example, this check is on, but this on is a condition, so there's only one condition I can get the result, so that is why the time complexity becomes on. So this is on and this is O1. Now let me submit it to check if it works. As you can see, it is much faster than before because the time complexity is on. Thank you for watching. See you next time.